The part of AI that changes your product is not training, it is inference. And most new builders obsess over the wrong half.
That is the key distinction. Training is when a model learns patterns. Inference is when you actually use the trained model to make a prediction, generate text, classify an image, or choose an action.
So the glamorous story is learning, but the business story is serving answers.
Exactly. Inference is the runtime moment. Input goes in, the model computes, output comes out. For programmers, it is the part your users touch, wait on, pay for, and judge.
Give me the simplest concrete example, because people hear the word and mentally drift.
Say you build spam detection. During training, the model studies lots of labeled emails. During inference, a brand new email arrives, and the model decides, spam or not spam. That live decision is inference.
And that one live decision can block a phishing attack or bury a real invoice. So this is not a technical footnote.
Right. Inference is where model quality becomes product reality. If it is slow, expensive, or wrong, users do not care how elegant your training pipeline was.
Why does this matter so much to programmers who are just getting into AI?
Because inference is where engineering trade-offs hit. Latency, memory use, throughput, cost per request, batching, caching, fallbacks, hardware choice. That is the daily work of shipping AI, not just reading benchmark charts.
So the power shift is this. The team that wins may not be the team with the smartest model, but the team that can answer fast enough and cheap enough.
Very often, yes. If your chatbot gives slightly better answers but takes 6 seconds, users may leave for a good enough system that responds in 1 second.
Let us make that practical. Suppose I am adding an AI feature to customer support.
A user submits, "I need to change my billing address, and my invoice looks wrong." At inference time, the model reads the request, maybe classifies intent, maybe drafts a reply, maybe routes it to the right workflow. Each step can be a separate inference call.
And if that chain is clumsy, the user feels every stumble.
Yes, a slow inference path means awkward pauses. A weak model means misrouting. An expensive model means your support cost explodes. Inference is where user experience, reliability, and unit economics collide.
There is also a common misunderstanding here. People use inference like it means reasoning, as if the model is sitting there thinking deeply.
That is the big one. In AI, inference does not automatically mean human-like deduction. It just means running a trained model on new input to produce output. Sometimes the output looks smart. The underlying step is still computation over learned patterns.
So when someone says the model is doing inference, they do not necessarily mean it is logically proving anything.
Correct. A face unlock system does inference when it checks whether your face matches. A recommendation engine does inference when it picks the next video. A language model does inference when it predicts the next token. Different tasks, same basic idea.
That also explains why inference can be cheap or brutally expensive, depending on the model and the job.
Exactly. A tiny model classifying sensor data on a device can infer in milliseconds. A large language model generating a long answer can require much more compute, more memory, and more careful scaling.
And now, the stakes get strategic. If every user request triggers heavy inference, your architecture is now tied to compute budgets.
Which is why programmers need to ask practical questions early. Does this feature need real-time inference? Can I pre-compute some results? Can I use a smaller model? Do I need one model or several specialized ones?
Give me another scenario where misunderstanding inference burns a team.
A team prototypes a code assistant with a huge model and gets great demos. Then real traffic arrives. Responses lag, cloud bills spike, and the feature gets rate limited. They thought model quality was the whole game. In production, inference efficiency became the real constraint.
So if training creates the capability, inference decides whether that capability is usable.
That is a clean way to say it. Training builds the brain, in a loose sense. Inference is the moment the brain has to perform on demand, at scale, under a budget.
Which means the first AI question for a programmer should not just be, can the model do this? It should be, can the model do this every time a user asks?
Exactly. Inference is AI under pressure. If you understand that, you stop treating models like magic and start building systems that actually survive contact with users.